we do not like degree 4 polynomials. They are not easy to solve. However, this one has a very nice structure, which allows us to manipulate nicely to solve for x. Check this out. Firstly, there's a product here, and this thing isn't really easy to manipulate, so with nothing to do at first, let's distribute this in. So we would get x to the 4 minus 4x cubed minus 4x plus 7x squared minus 2x is equal to 4. It might be tempting to combine the negative 4x and negative 2x. However, we might want to reconsider a little bit, because sometimes the most obvious path doesn't always lead to the answer. So, before we go on with combining them, let's first consider two identities. First off, you might be familiar with the identity x minus 1 to the 4th power. This, if you expand this, will be equal to x to the 4 minus 4x cubed plus 6x squared minus 4x and then plus 1. And another identity, and this is way more common, is x minus 1 squared is equal to x squared minus 2x plus 1. Now, these two identities, once we take a look at them, might give us a bit of an idea of how to continue on over here. In fact, if we were to consider the 7x squared term and break it up as 6x squared plus x squared, then now consider this. Consider the terms from x to the 4 to 6x squared. All of the terms are there in order to make the x minus 1 to the 4 identity, the expanded version of it. The only thing we're missing is a plus 1, right? And similarly, for x squared minus 2x, all we need, again, is just to add 1, and we can factor it into this form. So we're going to complete the 4th power and the square. That's a pretty good idea, right? Now that we've taken a look at this. So I'm going to first rewrite this expression so that it becomes a little bit more clear. Now, as I said, we're going to have to add 1 in order to complete the 4th power and square for this part and this part. So if we add a 1, we're done with completing the powers, right? And we can't just add 2 on one side for free, so you have to add 2 on the other side as well. So check this out. Notice that, again, this part factorizes as x minus 1 to the 4th power, and this part factorizes as x minus 1 squared, and this is equal to 6. And take a look at this. This over here is a quadratic expression in terms of x minus 1 all squared. In fact, if we were to let y equal to x minus 1 all squared, then substituting it into this yields y squared, and then plus y minus 6 is equal to 0. Moving the 6 over, of course. Solving this requires basic quadratic skills. Here, this one can be factorized as y minus 2 times y plus 3. And because they are in factored form, we can get the roots, right? Now remember, y is equal to this expression, so don't forget about that. Now, here we have y is equal to 2, if we consider this factor, right? So we get x minus 1 all squared is equal to 2. And we can solve this fairly easily. We can take the square root of both sides, yielding x minus 1 is equal to positive negative square root of 2. And then this gets us x is equal to 1 plus or minus root 2. So we already have two solutions, and they're both real. Now, this one over here, y plus 3, this factor gives us that y is negative 3. So we have, and by the way, I'm going to box one of our solutions, so over here. So anyway, this factor would give us x minus 1 all squared is equal to negative 3, right? And this one will require complex numbers. Taking the square root of both sides gives us x minus 1 is equal to positive negative root 3i. And moving the 1 over, we get x is equal to 1 plus or minus root 3i. And that's another solution. Those are actually two more solutions. So we're done because this was a fourth degree polynomial. So it has, well, 4 solutions. So these are our solutions. So as you can see, 2 real and 2 complex, 2 non-real solutions. So I really hope you found this video interesting, and I hope you learned something from it. Definitely be on the lookout for special forms, because they can really help you to solve equations. So yeah, again, if you found this video interesting, then please do consider dropping a like and subscribing. Thank you very much. Bye.